welcome to a video for IGCSE chemists, and this looks at how to balance chemical equations. Now this only looks at balancing the equations. It doesn't look at constructing the equations from a word equation. So it just looks at putting what I call the big numbers into the equation to ensure they're balanced. Let's get going. Right, so here are 4 equations that we're going to have a go at balancing. And to start with, I recommend that you make it like a mini table of the elements that are in your equation. And what we're going to do is we're going to ensure that we have the same number of atoms on the left of the arrow as we do on the right. And that's because in chemistry we don't destroy atoms. So the same number of atoms must go in at the start as come out at the end. So we're just going to do a bit of counting up now. We've got 1 lot of calcium there and 1 lot of calcium there. So I'll write calcium 1, 1. On the left we've got 1 carbon, and over here we've got 1 carbon. So 1, 1. And oxygen, here we've got 3. But on the right we've got 1 here. But we also have another 2 here. So on the right we have 3 oxygens. So you'll spot that the same number of atoms are on the left as are coming out on the right. So this equation, without us needing to do anything, is already balanced. But most of the time it's not that easy. Okay, most of the time they don't come to us already balanced. So let's have a look at the next one. Okay, so this is the reaction of magnesium in oxygen that you may well have done, and the magnesium glows that beautiful bright white light, and you form magnesium oxide. So let's have a look. How many magnesiums on the left? We've got 1, and on the right we've got 1 over there. Oxygens on the left we've got 2, and on the right, we've only got 1. Okay, so this equation isn't balanced. And what we're going to use is we're going to use what I call big numbers to ensure that we have the same number of atoms on the left and on the right of the equation. Now what I mean by that is, let's say for example I put in a 3 here. Now what that means is that I've got 3 lots of whatever comes after it. So I've got 3 lots of O2. So in total that means I'd have 6 oxygen atoms. Okay, if I put that number in front of a compound, it would do the same thing to the components of that compound. Now I'm not sure that 3 is necessarily the best place to start. But when doing this it might feel like you're guessing. And to start with, you are guessing. Okay, but you start to get used to the ways in which the equations work. You start to find it's not quite so much of a guess, and it's very difficult to explain. But you just have to have a go and be prepared to get things wrong. So you'll notice that our oxygen aren't quite right. So what we could do is we could put a 2 here. Now this is just a suggestion, it might be wrong. Now what that would do is it makes us have 2 lots of whatever comes after it. So it changes our magnesium atoms on the right to 2 rather than 1, and it changes our oxygen to 2 rather than 1. So we're no further forward, it might appear, because we're still not balanced. We've sorted our oxygens, but we've messed up our magnesiums. Our magnesiums were fine before. But if I put a 2 here, that means I just double the magnesium. And now we're balanced. We've got the same number of oxygens, same number of magnesiums, so we're balanced. So that works. So that was quite nice and straightforward. We only had 2 elements in there, magnesium and oxygen. And what I've done for the next one is I've thrown 3 elements in there. We've got carbon, hydrogen, and oxygen. And you might think at this point, actually I'd like to have a go at this myself. So in which case, pause the video, have a go at it and see if you get the right answer. So let's do our stock take, if you like, of carbons. We've got 1 here, and we've got 1 on the right. Next up we have hydrogen. We've got 4 there and 2 there. 4 and 2. And oxygen, we've got 2 on the left, and we've got 3 on the right. Okay, so it does appear that we are a long way off being balanced. Our carbons are sorted, so maybe we could leave the things to do with carbon alone without putting any numbers, but our hydrogens and our oxygens are way off course. So, why don't we start with trying to get the hydrogens up to speed? Okay, so we've got 4 over here and 2 here. So as a suggestion, I'm going to suggest we put a 2 here. I don't know if this is the right way to do that. I don't know if this is right or not. You just have to start off by plugging a number in and seeing how that works out for you. Okay, so we've got 2 lots of whatever comes after it. So that means we've got 2 lots of H2, which means we've actually now got 4 lots of hydrogen. So the rubber's not working, so I'm just going to put a 4 here. And it also doubles the oxygen that come after it. So we've got 2 lots of O, and we've got O2 here. So we've now got 4 lots of oxygen. So we've sorted out our hydrogen, but now we've got a much nicer ratio. We've got 2 lots of oxygen here and 4 over there. And it'd be quite easy to turn 2 into 4 by just doubling it. And that's our finished equation. Now when you report the equation when you're doing work, you don't show the table. Okay, that can be done on a scrap piece of paper, and the person who's marking your work or reviewing your work or whatever will just want to see the equation finished. So get an old piece of paper, I usually use an old envelope, and scribble things down on the back. Now we're up to 4 elements. So we've got magnesium, we've got hydrogen, we've got nitrogen, and we've got oxygen. And you'll see I've also included a bracket. Let's see how we get on with the brackets. So magnesium, I've got 1 here and 1 here. That's quite nice. Hydrogen, I've got 1 here and 2 over there. Nitrogen, I've got 1 on the left. Now the brackets make things a little bit more interesting with the nitrogen. I've got 2 lots of the brackets, and in the bracket there is only 1 nitrogen. But because I've got 2 lots of them, that means I've got 2 ends. And oxygen, well, I've got 3 here, and I've got 3, but I've got 2 lots of those 3, which make 6. So I've got 3 here, and then I've got 6 over here. Right, now this might appear really difficult, but if you're quick, you will spot that the hydrogen, the nitrogen and the oxygen on the left are half the values on the right. So if I stuck in a 2 here, that means I'll have 2 lots of hydrogen, 2 lots of nitrogen, and 2 lots of 3 oxygens, which makes 6. So actually that was quite quick to balance. That was quicker than the last one. Okay, now I'm a bit concerned about time on this video. There are another 4 equations on the next slide that I would like you to have a go at. I'll do them slightly quicker. Okay, so what I recommend is you pause the video, have a go at the next 4 equations, and then go through your answers by comparing them to mine.